SpinLaunch raised $30 million, but abandoned their Kinetic launcher to use rockets instead. This stunning pivot proves what Elon Musk predicted about physics limitations that no amount of funding can solve. What did NASA's data reveal that forced this dramatic change? We'll break down the technical reality behind SpinLaunch's failure and why traditional rockets still dominate space access. Back in 2018, when SpinLaunch first gained attention, Elon Musk made a simple but devastating observation about kinetic launch systems. The fundamental issue is that you still need to overcome atmospheric drag, and the energy requirements scale exponentially, not linearly. Most people dismiss this as competitive posturing, but here's what few people realize. NASA's own atmospheric physics data would prove Musk absolutely right. When SpinLaunch conducted their final test series in 2022, the results revealed exactly what Musk predicted. Their 33-meter accelerator achieved 10 kilometers altitude at 1,600 kilometers per hour. Impressive engineering, but exposing a brutal physics reality. To reach orbit requires 25,000 kilometers per hour at 300 kilometers altitude. And here's the critical detail most people overlook. This isn't just a scaling problem, it's an exponential energy wall. Think of atmospheric drag like swimming through increasingly thick honey. At SpinLaunch's test speeds, air resistance is manageable. But at orbital velocities, that same atmosphere becomes a crushing barrier that requires exponentially more force to penetrate. NASA's atmospheric density data shows why. Drag force increases with the square of velocity, meaning double the speed requires 4 times the power to overcome. But the real engineering nightmare begins with the launcher itself. Generating orbital velocity would require a 100-meter diameter accelerator, 3 times larger than their current prototype. The rotational forces inside that massive vacuum chamber would subject payloads to gravitational forces exceeding 10,000 Gs. We'll come back to this G-force problem later because it reveals why no amount of engineering refinement could solve SpinLaunch's core challenge. Here's where Musk's prediction becomes prophetic. Modern spacecraft predominantly use liquid fuel systems, which are hypersensitive to violent sloshing. SpinLaunch's system is fundamentally incompatible with 80% of today's payload market. Even if they solved the velocity problem, they'd be serving a shrinking niche of solid fuel customers in an industry rapidly moving toward liquid propulsion. And this leads to the timeline that reveals everything. After 10 successful suborbital tests in 2021 to 2022, SpinLaunch went completely silent on orbital development. No new tests, no construction updates on that crucial 100-meter facility, no technical breakthroughs announced. The physics wall Musk identified had stopped them cold. Meanwhile, SpaceX's Falcon 9 completed over 100 launches annually, with turnaround times measured in hours and 22-ton payload capacity per mission. First, SpinLaunch was chasing a moving target. Second, that target was accelerating away from them. And most importantly, their fundamental approach was fighting physics rather than working with it. But this is just the beginning. What's really surprising is how the financial data reveals the exact moment investors realized Musk was right. Following SpinLaunch's funding trail tells the story of a company quietly admitting failure while publicly pivoting to survival. But there's a remarkable discovery hidden in the numbers. Recent investments total $53.5 million, but none mention the Orbital accelerator that originally attracted investors. The breakdown is revealing: $11.5 million in 2023, $12 million from Kongsberg earlier this year, and now $30 million specifically earmarked for Meridian Space, their satellite constellation project. And here's what's truly noteworthy. They're planning to launch these satellites on conventional rockets, the very technology they promised to disrupt. This represents the space industry's brutal honesty about technical feasibility. Early SpinLaunch attracted venture capital based on revolutionary launch promises. Now they're raising money to become a traditional satellite operator using the rockets they once claimed were obsolete. Why would investors accept this dramatic pivot? Because the alternative was total loss on their original investment. And this is where things get interesting from a competitive standpoint. SpaceX's Starlink already operates over 5,000 satellites with continuous deployment capability. Amazon's Kuiper project is scaling rapidly with 3,236 satellites planned. OneWeb operates 648 satellites providing global coverage. By SpinLaunch's target date of 2026, these competitors will have insurmountable advantages in market share, operational experience, and customer relationships. SpinLaunch's satellite design does show innovation. Their 70-kilogram units eliminate bulky two-dimensional scanning antennas for streamlined panel configurations. They claim capability to launch 200 to 250 satellites per mission, potentially exceeding SpaceX's rideshare records. But here's the detail most people miss. Achieving this requires perfect execution on their first attempt in a market dominated by proven operators. The economic reality is stark. SpinLaunch now represents a customer, not a competitor, to the rocket industry. They've transformed from potential disruptor to dependent customer, illustrating how quickly the space economy punishes unproven technologies. What happens if their 2026 timeline slips? The satellite window could close permanently as competitors solidify market dominance. David Wren, their chief innovation officer, emphasized their reflector array antenna technology, achieving multi-band capability without traditional cost and complexity. But there's something larger happening here. This technical language masks a fundamental business model transformation from revolution to incremental improvement. And here's why this changes everything for the future of space innovation. SpinLaunch's transformation from revolutionary launcher to conventional satellite operator represents more than one company's pivot. It's a defining moment for how the modern space economy evaluates breakthrough technologies. And this leads to a remarkable discovery about innovation in space. The industry has matured beyond accepting theoretical advantages over proven performance. But here's what few people realize about the broader implications. Kinetic launch technology isn't necessarily dead, it's just found its wrong application. On the Moon or Mars, where atmospheres are thin or non-existent, SpinLaunch's accelerator could provide fuel-efficient payload deployment for early settlement phases. NASA's Artemis program and future Mars missions might eventually need exactly this capability, just not for Earth departure. This reveals a crucial pattern in space technology adoption. Revolutionary concepts often succeed by finding their appropriate niche rather than replacing existing systems entirely. SpinLaunch's accelerator might become invaluable for interplanetary logistics while remaining impractical for terrestrial launch. We'll come back to this niche application concept because it suggests how other failed space technologies might find unexpected success. The satellite market SpinLaunch is entering faces its own disruption dynamics. With 1,190 satellites planned for Meridian space promising tens of terabits per second connectivity, they're betting on differentiation through manufacturing efficiency rather than launch innovation. And here's what's truly noteworthy. This approach might actually be more sustainable than their original timeline-driven accelerator development. But there's something larger at work here. Success in satellites could provide SpinLaunch the revenue stream to continue accelerator development as long-term research rather than immediate commercial necessity. This patient capital approach might prove more effective than their original venture-backed sprint toward orbital capability. The competitive timeline remains brutal. SpaceX launches Starlink satellites faster than most companies can manufacture them. Amazon's Kuiper has committed launch capacity booked through 2029. What happens if SpinLaunch achieves their 2026 deployment target? They might capture enough market share to sustain operations, but they'll never achieve the market-defining position their original accelerator promised. And this is where the Elon Musk prediction becomes prophetic for the entire industry. His observation about exponential energy scaling applies beyond kinetic launchers to any revolutionary space technology. The physics of space access rewards incremental improvement over radical departure from proven methods. The coming years will determine whether SpinLaunch successfully completes this pivot. But what's truly significant is how their story illustrates the space industry's increasing sophistication. Early space ventures could attract investment based on theoretical breakthroughs. Today's space economy demands proven performance, reliable timelines, and clear paths to profitability. If SpinLaunch succeeds with Meridian Space, they'll have demonstrated that pivoting from failed innovation to market execution can preserve company value. If they fail, they become a cautionary tale about the difference between breakthrough engineering and commercially viable technology. Proof that in space, physics and market forces always have the final word. The ultimate lesson? Even the most ambitious space technologies must respect the fundamental forces they're trying to overcome. This is exactly why Musk's physics prediction proved devastating. SpinLaunch learned that revolutionary space tech must work with fundamental forces, not against them. Their pivot from launcher to satellite operator shows how modern space exploration rewards building on proven physics rather than circumventing it. And this is just the beginning. As we approach 2026 timelines for multiple constellations and lunar missions, the industry's physics-first approach will only intensify. How do you think this will impact other ambitious space technologies in development? Will we see more pivots, or can revolutionary concepts find their right applications? This is Space Hub. We dive deep into the engineering forces shaping space exploration. For more analysis connecting technical details to the bigger picture, hit subscribe. The future of space isn't just reaching for the stars. It's understanding exactly which technologies will get us there.